In this video, I'm going to show you a series of identities called the Pythagorean Identities. We've actually proved one of the Pythagorean identities already. Probably should have called it a Pythagorean identity. But if you remember, we proved that the sine of an angle squared, remember that's the same thing as sine of theta squared. The sine of an angle squared plus the cosine of that same angle squared is always going to be equal to 1. Okay, we already proved that. If you remember, I used a right triangle to show it. Okay, so that is the first of the Pythagorean identities. The other two Pythagorean identities for trig can be derived from the same statement. Okay, so here's the idea. If I have an equation, both sides are equal, which means I can do the same thing to both sides of the equation, and I should get another equivalent equation. Okay, here's what I'm going to do. I'm going to divide every single term here by the cosine function squared. Okay, so I'm going to divide this by the cosine squared of theta. I'm going to divide this by the cosine squared of theta. And I'm going to divide this by the cosine squared of theta. Okay, right, if I have an equation, every single term can be divided by the same thing. So I'm dividing all by the cosine of the same angle, that whole statement squared. Okay, and we can simplify this down. Now, using exponent rules here, and I'm not going to show this in every single example, but I want you to know where this is coming from, so when I don't show this in every example, you'll know what I'm doing. Remember back in Algebra 1, when you learned your exponent rules, if you had a fraction, the exponent for that fraction would apply to both the numerator and the denominator. Okay, so I'm going to rewrite this statement here. I'm going to say that this is the same thing as sine of theta divided by the cosine of theta squared. Okay, that squaring will apply to this and it'll apply to that. Okay, equivalent, just a different form. Okay, same thing here. I'm going to rewrite this as the cosine of theta divided by the cosine of theta, that whole thing being squared. Same thing over here. 1 squared is still 1. Okay, so what I'm going to do here is I'm going to write it as 1 over cosine of theta squared. 1 squared is still 1. We were supposed to have a cosine squared down there, still the same thing, okay? And we can simplify this, okay? So the whole concept with trig identities is we can replace values in a statement with other things that are equivalent. That's the whole idea of an identity, okay? So if you think back to previous videos, what's the sine of an angle divided by the cosine of the same angle? That's right, it's the tangent of that same angle. Okay, so I can replace sine of theta over cosine of theta with tangent of theta. That whole thing is being squared, so that would be tangent of theta squared. I'm going to write it as tangent squared of theta to use this more simple notation that we've been using. Okay, cosine of an angle divided by cosine of that same angle, anything divided by itself, is just equal to 1. Okay, over here, this is the reciprocal of the cosine function. Do you remember what that is? Reciprocal of cosine is secant. Okay, so it's the secant function squared. Again, I'm going to write it as secant squared of theta. And that is a new Pythagorean identity. The tangent of an angle squared plus 1 is equal to the secant of that same angle squared. All right, I'll write all these down at the end, but that's the first one. Okay, let's go back to my original statement here. My original statement was sine of an angle squared, sine squared of theta, plus the cosine of that same angle squared is equal to 1. Okay, remember I divided all the terms by the cosine. Okay, I can divide all the terms by the sine, and we'll get other identities. So I'm going to divide this by, actually not the sine, I'm going to divide all of these terms by sine squared. Okay, divide that by sine squared, I'll divide this by sine squared of theta, and I'll divide this by sine squared of theta. Okay, what am I going to get? Well, same thing here. I'm going to rewrite this with the whole fraction being squared. So same thing as sine squared over sine squared. Same thing here. I'm going to write this as cosine squared over sine squared. And then same thing here. 1 squared is 1, sine squared. Okay, same statement. Okay, let's simplify this thing down. Let's see what we get. Anything divided by itself is equal to 1. 1 squared is 1. Okay, this is the cosine over the sine of the same angle. Okay, remember sine over cosine is equal to tangent of theta. So cosine over sine is going to be equal to the cotangent of theta, and it's being squared, okay? And then finally, 1 over sine, that's the reciprocal of the sine function. That's the cosecant function, and it's being squared, okay? So that's our last of the Pythagorean identities. 1 plus cotangent squared is equal to the cosecant squared, okay? To summarize these 3 statements, so what facts do you need to know? The sine squared of an angle plus the cosine squared of an angle is equal to 1, okay? When I divided everything by cosine squared, I got the tangent squared of an angle plus 1 is equal to the secant squared of that same angle, okay? And the last one, when I divided everything by sine squared, I got 1 plus the cotangent squared of x is equal to the cosecant squared of x. By the way, because of the commutative property, I could write this as 1 plus tangent squared of x. I could write this as cotangent squared of x plus 1. I don't remember exactly how I wrote it on the slides. It doesn't matter. The big thing is secant squared is equal to a 1 and a tangent squared added together. Cosecant squared is equal to a cotangent squared and a 1 added together. By the way, one other pattern here. In fact, let me change the order of this just to make a point here. That's cotangent squared of x plus 1. I haven't used the term cofunction before, but cofunctions would be basically a trig function paired with co. So sine and cosine are cofunctions, okay? Tangent and cotangent are cofunctions. Secant and cosecant are cofunctions, okay? In pre-cal, you'll discuss some slight relationships between these, not really anything that's gonna affect what we're currently doing, but a nice little pattern here. We're gonna use this a ton, okay? I hope nobody has trouble remembering that first statement. The second statement here, notice tangent squared plus 1 is secant squared. Notice the last statement is just the cofunctions. It's cotangent squared plus 1 is equal to cosecant squared x, okay? These 2 statements are just cofunctions of each other, and that may help the memorizing process just a little bit, okay? So anyway, those are the Pythagorean identities. We will see uses for those down the road.